I've been told that a few of you guys are a little confused on when or when not to use the quadratic formula in a projectile motion question. So what I wanted to do today is share with you guys a new realization I've had that I've learned this week, and I think it's a very important thing to know. So I wanted to share it with you guys. So what it is that there's simply only 3 different types of projectile motion questions. I know that seems hard to believe, but because it seems like there's so many different ways you can solve a projectile motion question, but there are only actually 3 different templates that each have their own ways to solve. And if you learn this, then I think it would be much easier for you to classify a problem when you see it on a test and be able to apply the right methods to solve it. So I'll start by showing you the first and easiest one. What it is, this scenario, it's usually a cliff or an elevated platform, and then a projectile. Let's just say a ball is thrown off the cliff and lands on the ground this distance away. So this is the easiest. The main characteristic about this is that there is no VIY, or it's equal to 0. That means you don't have to consider any change in the whatever. So just remember VIY equals 0. Then another characteristic is that the h1, let's call this distance h1 and this h2. So h1, that's the height of the cliff. What it has to be is greater than h2. So this question, it's just something is thrown with a horizontal, usually with a horizontal velocity vector, off an elevated platform, and it lands a certain distance away. And this is pretty easy to solve. All you do is, if you're solving for d, then dx equals vx times time. And that's pretty much it. And you can rearrange these to solve for other things. And also, if you're given the height of the cliff, you can also use dy equals 1 over 2 at squared plus, since there's no vi, then you can just use that. Okay, this is the first degree of projectile motion questions. Now the second one, which is harder, and this is what we covered last year mostly. It's an object which is shot up into the air at an angle. It lands on the same level ground. So characteristic of this is that it has shot at an angle. So there's a VI component, VI with X and Y components. IX. And then also there's the DX. And that's pretty much it. So the way to solve this one is significantly harder than the last one. For this you have to use the dy equals 1 over 2 at squared plus VIYT. And for this one, usually since the ball goes up and lands at the same height as it ends up, then dy is usually equal to 0. And also another characteristic of this graph, which I already said, h1 equals h2. That's just the height from where they both start. Where it lands and where it starts is the same. So yeah, I think that's about it. I mean, there are other ways to solve this. Like if you're looking for VF, you have to use VF squared equals VI squared plus 2AD. But since that's harder, I won't cover that right now, and I'm just doing an overview. Now the third degree of projectile motion question. There's an elevated platform and the object lands at another height than where it starts. This can also be the other way, like an object starts up here and then lands down there, but it's usually this way. So the characteristics of this graph, there's a theta, and then vi, so there's viy and vix, just like the last one. And then also h1, h2. h1 does not equal to h2. So this is the main different thing that's separating these three, how h1 is compared to h2. If it lands lower than first degree, it's the easiest. If it lands same height, second degree, it's the second hardest. And then third degree, there's a difference in heights, and also VIY is exists, it's not 0. So this is the one where you have to use the quadratic formula. So the reason being is because in this question right here, in the second degree, dy does not equal 0. So you will have a third constant term that will, I'll just show you. So we have dy equals 1 over 2 at squared plus VIYT. And then from this, we change it to, since dy is not equal to 0, we move it over 1 over 2 at squared plus VIYT plus minus dy. So now here we have 3 terms, and our variable, if we say it's like, traditionally it's like 0 equals x squared plus 2x plus 1, then our variable x, this is going to be t in this case. And now you can see the similarities. dy is the constant 1, and the first term is the t squared. And then from this, since we're using in physics projectile motion questions, we don't have whole numbers like they do in math where you can factor. You actually have to use the quadratic formula to solve most of these. And if you haven't memorized it already, I highly suggest you do that right now. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. This will be very important to solve most of these questions that you will see. And these are new to me for grade 12. I'm not sure if other classes have covered them in last year, but this is what's the main new addition to this year for me. So, of course, this is usually you usually only have to use this if you're solving for t, and then, but also if you're solving for t, if you're solving for d, like h1 for example, then or no, actually like this distance right here, like the dx, then you also have to solve for t and then use d equals vt to solve that. So for either of those you have to use the quadratic formula, but also there's also times when you like if you're solving for theta, where you have to use a completely different method, and I'm not going to cover that right now since that's a lot more complicated. But yeah, that's about it. Let me know if you want another question, if going into detail on how to solve for each specific variable, but that's about all I wanted to show you today.